In topic 4 of module 4, we're going to be dividing radical expressions. And also, you may recall from high school, rationalizing denominators and, in some cases, numerators. So, let's move on. Now, when we are dividing, keeping in mind that get my pen working here. If we think of this, this is actually 4 to the 3rd power. And this happens to be 7 to the 3rd power, and that's a little tricky. Then taking the 3rd root of both of these just becomes 4/7. Now here again we have some easy ones. If we're going to take the square root of 25, that is 5. And then we're going to separate this into x to the 4th, and then an x. X to the 4th is going to be x squared. And on the top, you're going to be left with an x. And then this is a perfect square down here. So this is going to be 2y. So I sort of left out some of the middle step here, but these would be shortcuts that you might take as well. But let's write this out then. So we're going to have the 5th root, and keep in mind you can separate them like so. Into 2 parts. So here the perfect 5th of a to the 9th would be a to the 5th, and then a to the 4th would be left over, and this would be b to the 15th, and this would be c to the 15th, and then you would have a c left over. So again, at this stage, some of that might be left undone or mentally, but if you want to write it out, that would be fine. So on the top here, this is going to be an a, and this would be the 5th root of, and I guess I can do this line like so, a to the 4th there, and extend this down actually, and this would be b to the 3rd, c to the 3rd, and then under the radical sign we'd have this c. So again, cleaning this up just a little bit here, I guess this is what the answer would look like. And you saw how we did it step by step. Now, another technique that we could use is put this all under a common radical sign, and then simplify this. This is going to be 5 will go into there twice, and 24 times. So we could do that. Now with our 24 that's left, we could simplify that into the square root of 4 times the square root of 6, separating that, And the square root of 4 is 2, the square root of 6. Now for this one we have 5/4, or let's put that's better, 4/5, and then all of this under a common radical sign, where 5 will go into there evenly, so we get 4/5, the third root of 125, which is a perfect third, which then becomes 4/5. The third root of 125 is 5. Here the 5's cancel out, so our answer here, once we finish, is 4. Alright, now for this one, again, under a common radical sign, 21x to the 7th, y to the 10th, being sure you copy it down correctly, 3x squared y. There we go. So now we simplify, and we get the fourth root. 3 goes into 21 7 times. Subtract the 2 from 7, x to the 5th. Subtract a 1 from the 10, this is y to the 9th. And then we go and separate that into perfect fourths. And 7 doesn't, so we put the 7 over there. But x to the 5th, we can take x to the 4th and have an x left over, y to the 8th and have a y left over. So then this, when we take the fourth root of it, is x y to the 2nd, and then the fourth root of 7xy. And that looks good. Now, when we see a radical like this, and they're asking us to rationalize each denominator, the strategy would be to put them in separate parts, like so. Now again, some of this could be done mentally, but I'll show you all the steps. So on the top we have this, and on the bottom we're going to have the, I'll just do it here, square root of 4 times the square root of 2. So what is the square root of 4? 2. 2, the square root of 2. Now we want to change the square root of 2, which is irrational, into a rational number. So what we can do always is multiply anything by 1, but the form of 1 that we're going to use here is square root of 2 over the square root of 2. So here my numerator becomes the square root of 10. My denominator becomes the square root of 4, which is another 2. So 2 times 2 is 4. Now we have rationalized that denominator. Now this is one way to do it. Another way of doing it would have been, and let me show you, that this is the square root of 5. This is the square root of 8. What do we multiply the square root of 8 by to make it a perfect square? Well, it could have been, you might say 8 times 8 is 64, but that's too big a number. You could multiply this again by the square root of 2, and this by the square root of 2. This gives you the square root of 16, which is 4, and our numerator is the square root of 10. So again, another way of doing that. Let's go on to B. Now the square root of 8 up on top, I hope you'll agree, is 2 now, the square root of 2. That's what we've changed the top to. But our bottom is the square root of 7a. Now we're going to rationalize our denominator here by often just multiplying it by itself, which is the square root of 7a. And you must do the top as well, because the square root of 7a over the square root of 7a is a 1. So now my top becomes 2, this 2, the square root of 14a over, and when you multiply a radical with the same base by itself, it just becomes the radicand, 7a. Now, nothing can cancel here because this a is under the radical. You can't cancel it. Okay, let's analyze this one here. We have the third root of x squared over the third root, and watch how I'm going to write this as 5 times 5 y. So what would I multiply? And that third goes there. What would I multiply this denominator by to get this to be a perfect cube? Well, I'd have to multiply it by another 5 and a y squared. So to multiply this by 1, I have to multiply my numerator by that as well. So my numerator now becomes the third root of 5x squared y squared. But my denominator, I have 3 5s, so that would be the 125. Cube root of 125 is 5. And I have y to the third, so that's just plain y. And I have rationalized now my denominators. And this is the protocol, the way we did it to get our answers. I recall one time when I was doing math lab problems, and had I read the instructions, it said rationalize each numerator. Well, I was on the rationalize the denominator kick, so of course when I put them in there, they were wrong. And this was actually a quiz me, because I don't often do the practice, because I already know how to do it, and I think I'm so smart. Anyway, but here we want to rationalize the numerator. So, and I gave myself some workspace here. So, square root of 12 is the square root of 4 times the square root of 3 over the square root of 5. So this will be 2 the square root of 3 over the square root of 5. Now we want to rationalize the numerator. So I'm going to multiply this fraction by the square root of 3 over the square root of 3, which is a 1. This now becomes the square root of 9, which is 3. 3 times 2 is 6 over the square root of 15. And that's where I got it from. So again, part of this you could maybe skip this step and put this here, but again, we're showing you step by step how we have rationalized our numerator. And then for this one, we have the third root of 3a over the third root of 6b squared. Now we're going to multiply our numerator here by 2 more 3's, which is a 9. So I'm going to show that. Going to have to multiply that by a 9, so we get 27, which will be a perfect cube, and then this is going to be a to the second. Now I'm going to multiply my denominator by 9a squared also. But keep in mind here that this 6 is 3 times 2. So in a sense, I'm multiplying this 6 by a 9, and 9 is 3 times 3. So you'll see what's going to happen here shortly. So this then becomes the third root of 27 a to the third, which is going to be a perfect cube, which we'll simplify that in a moment. But now this becomes the cube root of 54 a squared b squared. So we're going to start to simplify. So this is a perfect cube, which is 3a. Now, our denominator, interestingly, we could fiddle with it a little bit more and get the third root of 27 times the third root of what's left over, 2a squared b squared. Well, what is the third root of 27? Well, that's a 3. And then we're left with, under the radical, with a third root of 2a squared b squared. And we can simplify a little bit, because this is 3 now over 3. These cancel out, and then our super final answer is a over the cube root of 2a squared b squared. Wow. Now, interestingly, in our booklet down at the bottom, they're giving this as the answer, and they should really simplify. This is a good answer. You've rationalized our denominator, but I would expect this. So if you did that, I would count this as full credit, and of course this is as full credit. All right, we'll wrap this up.